remembers what vocabulary words we talked about yesterday? Yes?
Fraction equivalent.
Yep, equivalent fractions, right? So what does equivalent fractions mean? Yeah, so you can look at a smaller fraction, like 1/2, and then look at like 4/8, a bigger looking fraction, and they can be equivalent, right? What other vocabulary words did we talk about? Yep, compare, and we're going to go more into comparing today. So do we see my wonderful shapes and stuff up here that we're going to look at today?
Yep.
Okay, so if I look at this, what would my fractions be in?
4.
Well, I want to be 1/4 because I don't have anything colored in, right?
4.
Fourths, right? And don't be afraid to just shout out at this time, okay? What about this one?
8. 16.
Yep, 16ths. I see a little bit more. This one?
4. 8. 4. 6.
Right? And then these ones, I don't have anything set yet because we're going to do that ourselves. So if I color in our nice little part here, what fraction does that represent? 1/4, right? Okay. All right. How many of you guys have seen the alligator mouths mean greater than, equal to, or less than? Right? So I'm going to put these here. So I'm going to have my greater than, my equal to, or my less than. Because my alligator mouth is either going to face the greater than, and that's going to be less than. It's either going to be equal to, or it's going to be this is less than, and that's greater to, right? Does that make sense for alligator mouths?
Yes.
So if I have those colored in, what is my fraction over here?
3/16.
3/16, right? So if I'm looking at my alligator mouths and I'm comparing my fractions, right? Which one looks bigger?
1/4.
1/4. Why do we say 1/4's bigger?
Because it shows a whole square and we only have a tiny piece of square.
So let's look at the big area. So if I'm going to look at this big area right here, and this, does that look like the same size square?
Yeah.
Yeah. But is that one all shaded in?
No.
No, it's not. So which one would we say is bigger?
1/4.
So which one am I going to circle?
The greater than.
The greater than?
that's facing this.
So that one, right? So we just compared that 1/4 is bigger than 3/16, right? Yeah. So what if I color in that? What fraction do I have here?
3/4.
3/4. You guys are getting really good at identifying fractions, aren't you? And so I'm going to do my little alligator mouse again, right?
Yep.
So I have greater than, equal to, or less than, right? Okay, and what if I color in,
5.
let's do
Wait,
that.
is that in the middle or
All those are drawn.
So what fraction do I have here?
5? 5/8. 5/8.
5/7?
5/8.
So how many do I have colored in?
5.
How many total do I have?
8.
So what is my fraction?
5/8.
5/8, right? All right. So if I'm looking at total area, which one do you guys think is bigger just by looking at the picture, left or right?
Greater than.
You say greater than?
Yeah.
Why do we say greater than?
That has more space. Over there.
More space, right? So let's look around my fraction. So if we look at my little red boundary, what do we see? What?
That one's more.
That one's more, right?
That one has a right angle, but that one is slightly tilted.
Tilted, right?
Upward.
But it's not a, so if it was right here, would it be a 90-degree angle?
Yeah.
Yeah. So what do we say, this one's greater than?
Yeah.
So we just compared that 3/4 is greater than 5/8, right? All right, good job, guys. So if I have my, what was this one again?
4.
8. So I have that colored in, what is my fraction there?
2.
So I'm going to do my greater than, equal to, or less than, right? And my, so if I color in that,
That's wrong.
what do I have there?
4.
4/8, right? So is that going to be greater than, equal to, or less than?
Equal.
Why is it equal?
Because they have the same amount.
So because it's cut down the middle, right?
Yeah.
What other fraction could that be if we wanted to look at equivalence?
It could be.
What if this line wasn't here, this line across?
Oh.
If I didn't partition that line there?
It would be 1/2.
1/2, right? So does that mean 1/2 is equal to 2/4?
Yeah.
And is equal to 4/8?
Yeah.
So we just compared that 1/2, 2/4, and 4/8 are equal to each other, right?
Yes.
Making them equivalent, right?
Yeah.
So let's look over here. What fraction do I have there?
1/2.
1/2, right? So if I wanted to show an equivalent fraction, how would I show it?
By taking the next one and making
The
it
whole
2/4.
So turning this into fourths, right?
Yeah.
So then that equals 2/4, right?
Yeah.
So that shows that that's equal, right?
Yep.
So is 1/2 and 2/4 equivalent to each other?
Yes.
Yeah? Thumbs up if you guys think it's equivalent. Alright, so if I draw that, what's my fraction going to be?
2/3.
2/3. And how do we know it's 2/3?
Because there's
'Cause I-
3 spaces.
Because I count my jumps right. 1, 2, 3. So I know 3 is on the bottom, right? And if I go 1, 2, right? How many of you guys mix that up when you guys count the like the top and bottom? So like if you have your fraction here and you say it's 2/4, but you write it 4/2. How many of you guys mix that up every once in a while? Yeah, I do too because it gets confusing. If you want to count it right, I always say let's start at the top because my top part is the numerator. So I start at the top. So I know that top number first, right? So I'll be like, oh, well I know that 2, because you want to say it in that order, right, that you do it, and then you count the bottom, and you see that there's 4, then you know 2/4, right? Because when I do stuff, I like to do it in order. I don't like to do it in opposite order. That mixes me up, right? How many of you feel like when you first did it, it mixed you up because you did the bottom part first and then did the top, right? So does it seem helpful to do the top first so that you're like, oh, that's my top number because that's where I need to stop. And then that bottom is the whole, all of the parts, right? So what fraction do I have here?
1/4.
1/4, right? So what if I wanted to partition that? How would I show an equivalent fraction to that?
Put it in the middle of each line.
Cutting all those pieces in half, right? What is that
Cutting
called?
all those pieces.
What's our
Partitioning pieces.
partition? That's our big fancy word, right?
Or
Partition.
decompose. Or iterate.
So if I just partitioned, right, what is my equivalent?
2/8.
2/8, right? So if I wanted to compare number lines, let's say I have that. Okay, so what is this fraction going to be?
2/3. 7/8.
This top one?
2/3.
2/3. So we're going to count over 1,
1,
2, right? So I'm like, oh, there's my 2. Then we're going to come over 1, 2, 3, right? Oh, there's my 3. 2/3, right? So what about this one? How are we going to count this one? What should I do first?
The top.
Should I- Who says we do the top first? Thumbs up. And say bottom for thumbs down because bottom thumbs point down, right? We can do either way, right? Let's say we want to do top first just so we can remember that top number goes first, right?
Yeah.
Let's count.
1, 2, 3, 4, 5, 6.
6, right? So we're like, oh, that's my top number. What about the bottom?
You have one now.
All right, so
1, 2, 3, 4, 5, 6, 7, 8.
8, right? So if we look at these fractions on our number line, which one looks bigger?
6, 8.
6/8. Why does it look bigger?
Because it
It's bigger because it has more parts?
Wait.
Well, my number
But you don't have
my number lines are the same exact size though.
Yeah, so they're the same.
I made sure they lined up. So if I draw my line down, 2/3 coming down is the same as 6/8.
No. Yeah, wait, if you didn't make your line slanted. Wait, the 2/3 lines aren't that quite equal. The last one is a bit bigger.
Yeah?
Yeah.
How about let's look at it this way. Let's draw our fractions. Okay, do those look pretty? The lines pretty even? Yeah? So I'm gonna color in 2/3, right? Okay, how many am I gonna color in here?
6.
So 1, 2,
3, 4, 5, 6.
right? There's still 2 left though, but let's look at this big spot right here, and this one. Which, they're not the same, are they? Which one looks bigger? The top one, right? So which one's the bigger fraction?
The top one.
The top one's a bigger fraction?
The bottom one.
So if I cut brownies, and I wanted to know how much I had left, would I show the big one or the little one to show which one I had more?
The
Because
one
you want
that
to.
has the smallest more.
So which one did I eat more brownies?
The bottom one.
The bottom one, right? So do we see how even if it's really close, there's still going to be a fraction that's bigger, right?
Yes.
They're not all going to, if both are weird and big, they're not going to be the same. There's going to be some fractions that are the same. If I cut this again, what would that fraction be if I cut it again?
4, 6.
4 or 6, right? So that's equal, right? What if I cut out that? So now I have
3/4.
3/4, right? So those are equal. So is 3/4 bigger than 4/6, or is 4/6 bigger than 3/4?
4, 6 is bigger than 3/4.
But you just said 6/8 was bigger than 2/3.
3/4 is bigger than 4, 6.
Because these fractions are equivalent, right? And these ones are equivalent, which means that our equivalents, this one's going to be bigger than that one, right? Just because we made the fractions equivalent doesn't mean that it changes the size that we're given, right? Because we still have the same amount, right?
Yeah.
All right. So today we're going to be playing with pizza.
Pizza delivery.
Well, you could say that, but we're going to be playing with some pizzas on our math notebook.
Actual pizza?
Okay? I wish.
Oh.
Maybe that's what I'll do for your last fun activity is maybe think of some fun pizza idea. Okay?
Cat idea.
All right. Well, I'm going to go shut off the video.
Take pizza delivery.
Okay? So don't turn around until I say it's okay, all right? And then I'll get us started on cutting our stuff, okay?
Do we get to take them home?